สวัสดีครับ Good evening, dear member and guests. Welcome to our monthly technical meeting. We hope you are all well and healthy during this challenging period. For those who do not know me, my name is Panit Jesadawaranon from Mubadala Petroleum, and I am the Vice Chairperson on this program. Today's meeting will be the topic of single trip dosing completion enabled by shape memory, polymer sand control, and multitasking valve. Presented by Parvinee Chaemchaeng. This presentation would take 30 to 40 minutes. So of course, if you have any questions, please leave them in Zoom chat box. If you prefer to ask in person, please leave the message in the chat box and let us call your name. Our mission and vision. Typically, we would hold this event in a hotel for social gathering. Unfortunately, we cannot do it under this climate, and we have to do it with online webinar. Having said that, we still continue with our mission to keep you informed of what's going on in our industry, make new knowledge available to you with our monthly technical presentations. Our vision is to be open to share information with our peer and across company, so we can provide energy for our kingdom. And of course, we can meet many new faces, and we hope to see a smile on your face very soon. With a similar format, we start with our section announcement, updating you with SPE Thailand status, following by the presentation by Parvinee, which is the main program for tonight. Then once speaker has answered a few questions, then we move on with the Q&A closing remarks. Please note that our section is now also recorded and shared on YouTube Live, or you can go to our SPE website to our link, and you can see the recorded event as well. SPE Thailand section has valid membership over 600 members, combining 268 professionals and 362 student members from Chulalongkorn, Suranari, Prince Songkhla, and Chiang Mai universities. Not only to retain, but we also have 21 new professional members since the beginning of the year to date. As you could see, we still have around 154 professional members from 2020 who has not yet renewed their membership. So may I remind you that please recheck your membership status. If lapsed, please consider to renew it. You could also consider to renew your membership with e-membership with only $20 annual fee. These companies are our sponsors who support us. Our SPE Thailand monthly technical meeting for this season. For any of you who may have just tuned into this meeting, if you would like to see your company logo here, please reach out to us, any of board member. We appreciate your support, and of course, our societies need you. Thanks again to our speaker, and most importantly, thanks to our section sponsor here. Here are our SPE Thailand technical meetings. The upcoming meetings are on 21st of October we have a joint technical meeting with SPWLA on the topic, a practical physical workflow for hydraulic fracture simulation by Kun Ryan Banas. In November, we have our monthly meeting on the topic, extreme robots offshore, the challenges by Kun Simon from Robotech. And in December, we have SPEDL or Distinguished Lecturer Program from Kun Ian Phillips on the topic, what does the future look like for the oil and gas and energy sector, the energy transition. So hope to see you all in this meeting and hope that we can soon have a face-to-face meeting very soon. On our neighbors, SPWLA Bangkok chapter also conduct a webinar session on the topic, a critical review of rock typing approaches in clastic reservoir by Kun Thanapala Singham, custodian petrophysicist from Petronas. So this will be held on Thursday, 30th of September, 3:30 p.m. So if you are interested, you can register in SPWLA Bangkok website. And of course, you can reach us via different platforms. You can go to our official website at thaispe.org to find more information for the upcoming events, new announcement, young professionals, student scholarship, and much more. You can follow us on Facebook. You can pick up your phone and take a QR code from here, or you can follow up us on the LinkedIn as well. Without further ado, let me now hand over to our program chair, Kun Kasien, who will do the honor of introducing our speaker tonight.
Okay, thank you very much, Krab Kun Panit. It is a very informative information that you share with us on SPE Thailand. And it is my honor to do the speaker introductions for tonight. My name is Kasien Sintuong. I'm the SPE program chair. So our speaker, after her college graduations, she joined Baker Hughes 3 years lead field engineer development program. After the program completions each year, she was working as an account manager, sales manager, and then operations manager for Thailand and Myanmar. Her current role in business development for sand control completions, responsible for Asia Pacific, where the responsibilities includes developing business strategies, initiatives to improve Asia Pacific financial performance, and implementing newly innovative products for the region. She also very active and have been presenting in SPE international event on several occasions. But ladies and gentlemen, please join me for a warm welcome to our speaker this evening, Kun Parvinee Chaemchaeng, Asia Pacific Sand Control Business Development Manager from Baker Hughes. Now, Kun Parvinee, you may take over the screen and share.
Thank you very much, Kun Panit and Kun Kasien. I will share my screen and please let me know once you are able to see.
Yes, we can see your screen.
Okay, perfect. So my name is Parvinee Chaemchaeng. You can call me Par as introduced. I'm working at Baker Hughes right now under sand control. And today I have been invited to speak on a case history, which we have implemented in Malaysia for a well. And the design of the completion was pretty much a single trip dual string completion. But what's special about this well is we have implemented the shape memory polymer sand control screen and the multitasking valve. These two technologies, I would say that it would be this well is pretty much the first implementation in Southeast Asia itself. However, before I do go into technicals, I wanted to save just a few minutes to share a quick HSA moment, which has happened to me recently as a sharing to the team here. So my topic is kind of, might be different from a lot of the HSC moments you've seen, but it's on kitchen fire. So not too long ago, especially during the COVID, you know how everyone starts having hobbies and they're like, oh, it will be a good idea to cook. Well, as you know, a lot of the Bangkok life that we have, we definitely prefer to buy in, but because of COVID, cooking has become a hobby for many people. And that is pretty much to say the same to my family and especially my mother. One day I was sitting just working as normal, work from home, and then my sister comes into the room like, our kitchen's on fire. So everybody panicked on what to do. And we didn't have a fire extinguisher, a proper one at the very least, but I did manage to stop the fire from going forward. There was some damage to the kitchen and we had to remodel a few things. However, in general, we took that as a lesson learned. For my mother. And also we actually purchased a new fire extinguisher to be placed at our kitchen. It is a pretty good thing. So I wanted to send a friendly reminder on how you use fire extinguishers. It's a pretty common thing that you can find in any building, as well as at the workplace of people in the petroleum energy. For sure, you would know the basics of it, but I just wanted to repeat one more time on how you use it. First, you pull the lever, the pin out, you aim at the fire, the base of the fire that is, you squeeze and just sweep through and slowly pretty much extinguish the fire. But make sure that you find the correct fire extinguisher for the mode of fire in that area. So yep, that was my safety moment. If there's any comments, feel free to put into the chat, or if you want to share anything on this HSC moment, please feel free to do so as well. Okay, so moving next. I will brief you a little bit on the agenda. As I have mentioned before, this is pretty much a sharing on a case history, which was really implemented in Malaysia with the use of 2 new technologies for Southeast Asia. I will go into pretty much the very basics of the technology first. So I'll go through the shape memory polymer screens technology, as well as the multitasking valve technology. And then we'll dive deep into the case history from the planning stage all the way to the execution for this well. Now, starting with the shape memory polymer sand control screen first, we can pretty much call it for short SMP screen is what I will be referring to it in this presentation. So what exactly are SMP screens? I think if you're a professional in the industry, you probably would be familiar with your typical screens from a wire wrap screen, a premium mesh screen, and so forth. We have expandable screens, alternate path screens, and so forth. So this is pretty much a new type of screen, which mechanism of the screen is quite different from the rest that you are familiar with. However, it still does remain to serve the same purpose, which is to put sand control or as a media for sand filtration of your production into the well. Now, so the SMP screen comes pretty much as a typical assembly of a screen that you have seen, an R3 joint with cartridges of the SMP on there. It is run like a standalone screen in terms of operations, run to TD. And once you reach TD, you pretty much pump an activation fluid in order to soak the material that you see on the base pipe. So the SMP that I'm referring to is this pretty much where my mouse is, the gray cartridge that you see here. So when you run it in whole, it'll be in a compressed state. And then once you pump the activation fluid and leave the activation fluid in the well, it will expand and conform to the well bore, giving it a positive energy, and pretty much gives you the sand filtration. Now, the application of an SMP screen is pretty much equivalent to a gravel pack system for open hole. So as you know, with gravel pack operations, it's actually very complex. The logistics of it, of having to mobilize pumping equipment, pump the gravel, pump the fluids, this and that, is quite a hassle. So that's where we took all the pain points and came out with this technology. And this technology is pretty much a lot more simpler in terms of logistics, HSE, as well as implementation of it itself. So just moving on a little bit deeper into the technology. At the time that we were considering the technology for this well in specific, the shape memory polymer screens had a limitation in pretty much temperature. As you know, every polymer are sensitive to temperature, and with this, that pretty much is the same for the SMP screens. So the limitation of it was at 200 degrees Fahrenheit. However, at now present today, we have pushed the boundaries to be with a new material to be able to accommodate 250, but at the time of the consideration, it was definitely 200. With learning through university science and engineering, you would know that materials have a glass transition temperature. And this is pretty much a temperature at which a material meets and you are able to change its shape. So you can modify its shape. So pretty much this is the concept behind how we create and manufacture the SMP3s. So let's say I'm going to choose just one size for reference. So let's say you go with a 5.5-inch base pipe for applications in an 8.5-inch hole. You would have the SMP material manufactured and extruded onto the base pipe at an 8.5-inch OD. But once we increase the temperature in the system while we're manufacturing, it will reach the TG of the material itself. Then we will use mechanical forces to squeeze it and compact it down into a smaller OD. And then we put down the temperature during manufacturing, and it will keep it in the compacted form at normal temperatures. So pretty much we're compacting it without disrupting the structure of the material itself. So with this compacted size, we run it in the hole in the actual well. And with the activation fluid, what happens is that the activation fluid, once it hits the material, it lowers the property of the SMP material down to have a lower TG, glass transition temperature. And with that temperature in the well, it will cause the SMP material to expand and conform to the well bore. So basically, if you look at this picture, initially is this picture where my mouse is. So this is how we manufacture it at the original OD, outer diameter of the base pipe. Then we compact it down to a stored one, and this is pretty much what we run it in the well. And once we run it in the well and it's ready to expand, we pump the activation fluid and it recovers back. So it's pretty much hence the name shape memory polymer screens. Now, as I mentioned, just to emphasize again, this technology of screens is not equivalent to a standalone screen, more in the commercial side. However, the technology is definitely very beneficial in terms of HSE risk, carbon dioxide reductions, and such like that for open hole gravel pack applications. Now, moving on to the second technology. Let me just check. If there's any questions, do let me know. On the second technology that I will be introducing today is multitasking valves, or another shortened version is what I call the MTV. Now, with running screens in a well, usually for sand control, it tends to be highly deviated or horizontal wells. You would be running the lower completion. So this is pretty much a simple schematic of it. We have the casing here and the open hole over here. And then you run the lower completion string. So at the bottom, you would have a bull nose, the seal assemblies and such like that. Then you have screens, as well as swell packers or open hole packers, depending on the requirements of the well. And then you would have a gravel packer or a liner hanger, depending on what you will use to hang the screens for standard standalone screens. Now, if you just run the lower completion without an inner string, because you do not have only base pipe, but you have screens in your assembly, when you're pumping down hole, you would be pretty much pumping out of the screens. So you would never be able to pump down to the very bottom of the well. So that's where lower completions, in almost all lower completions, you would require to run a wash pipe with it. So once you finish running your screen, then you would run your wash pipe assembly, which is the inner string, and then run the whole assembly all together down to TD. And what the wash pipe does is give you the capability in order to pump through down to the toe. And what this is actually pretty important for very deviated or horizontal wells, where while you're running in hole, there would definitely be a higher friction of your assembly, causing you to get stuck or whatsoever. So having the ability to pump and circulate out of the end of your assembly is quite important for those instances. But now, having this rush pipe run, for one, there's additional cost of the additional inner string, as well as you would be pretty much using rig time in order to connect the assembly of the wash pipe again. So that's where we took the challenge, and we looked at what can we do in order to eliminate this excessive requirement. And that's where the MTV comes into play. So what the MTV does is it's actually a feature that you can integrate into any screen joint and any screen or any AICDs, inflow control devices, or you can have it as a normal only assembly on a base pipe as well. And what it does is it's pretty much plugs the flow path of the screen, if you do have one. And so while you're running the outer string, the lower completion itself, you're able to pump down to the very bottom because the flow path would not go out through the screen. So that's pretty much the concept of the MTV. Now, this is probably a better drawing to show you what one screen joint will look like. So this is pretty much one screen joint, one R3. You have the screen here for sand filtration. With a typical screen, you would have a perforated base pipe, so the flow will filter through the screen and into the liner base pipe for production. But in ICDs or MTV's scenario, you would pretty much be producing through the filter itself as well, but the flow will be through this annulus between the screen and the base pipe coming down, and it will hit here where the multitasking valve is placed. So this multitasking valve is blocking the flow. However, when you're ready to have that flow, this yellow multitasking valve will come out of place, and you will reinstate the flow from the MTV housing into the base pipe for production. This is pretty much a similar diagram that I wanted to show, but this is with integration of an inflow control device as well. So it's kind of cut out, but on your right, that doesn't have the picture would be your screen. It will flow through the micro annulus again, blocked by the MTV, and once this comes out, you'll be able to flow down and into the AICD, the inflow control devices, and go through production. So the MTV pretty much works on many types of screens and installations. This one, just to give you an idea of the flow path while you're running in hole. So at the left is the top of the joint, while the right is the bottom. So you would still have while you're running a hole, the MTV would be in place, right? So when you're circulating, you pump down. Usually it will go through the screens, but with an MTV assembly, the flow is blocked here at the MTV. So you can pretty much pump down to the bottom of your lower completion. So once you're at TD and you're ready to activate the MTV or even set your packer at the very top, you pretty much plug the end of your assembly. This plug can be anything from a ball seat, and you just pump a ball, or even a wiper plug seat or anything like that. But as long as you're able to plug the very end and pressure up, so when you're ready to activate it, you pressure up, and what it does is the pressure goes into and pushes this valve, and this valve will share a shear pin inside. Once you bleed off the pressure, because the shear pin is already broken, the spring that you have on the valve will pretty much push out, like bounce out the valve out of its place and create that communication. And you'll be able to produce through the screen again. So once you activate everything, you just produce through the screen down the ICD, if there is any, through the original MTV housings and into the production stream. Okay, so this is just a case history of the MTV technology, which is actually an SPE paper written quite a while back. And I think it's a good showcase of the benefits of the MTV in the sense of it was a case history in the Middle East. They ran 2 wells with the almost exact same length of TD. However, the open hole length was quite different. And you can look at the graph here. The blue lines indicate the well with MTV, a total of 75 joints, while the yellow is the screens with ICD without any MTV. So you can see that there are a lot of steps in the operations, from making up the inner string, setting in the open hole packers and such, pulling out the inner string. These are pretty much rig time savings that were saved because of the technology. And you can refer to the total time that with using the MTV, they had a total of around 48 hours operation time, rig time. But without the use of an MTV, you go with the conventional way of how you run the lower completion. They used around 90 hours for that completion. And do note that the MTV system was a total of 75 joints, which is pretty much 50% more joints than the ICDs. And it still gave lower time. So you can definitely see the rig time savings on those. Now, since I have introduced the two technologies that we'll be touching base on, we'll dive into our case history, which is an installation in Malaysia. It was done just recently recently, I don't really count the COVID area, but it was during November 2019. And this is pretty much, I'll call it well A. You can see the schematic of the well on the right. This is a field, a pretty much brown field that has been producing for a while. So each well that they do produce from 2 zones. So the top zone is gas sand X and the bottom zone is oil sand Y. With the oil sand Y, they require inflow control in order to maximize their production. So inflow control devices were definitely a requirement on the bottom zone. At the top zone, it was a gas zone, and usually they would pretty much do completion with a case hole gravel pack or an open hole gravel pack at this section. But the customer would definitely do a dual string production. So production from the oil sand Y would go through the ICDs normally and produce up the longer string, while the production from the gas sand X will produce from the top and produce through the short string. The 2 strings are segregated by isolation though. So that's where applications of an SMP as well as MTV was introduced. I'll talk into detail about that later. But just starting with the completion design itself, with their conventional way of doing the completion with a gravel pack at the top and ICDs at the bottom, one challenging thing we saw was when we were looking at the torque and drag of the assembly, and there was signs of possible helical buckling in the casings and such like that. So for one, we definitely needed to lower the weight of the lower completion string to avoid these bucklings that could occur. So when you run, as I mentioned, run a lower completion, you would definitely need pump down capability, hence the wash pipes and so forth, so you can pump down to the bottom. And it provides well control as well. However, in order to lower the weight, it would be beneficial if they didn't have to run the wash pipe, because that's the weight of the whole wash pipe assembly, and throughout an interval of around 2,000 meters. So that pretty much justified using MTV into their ICD screens, and that will eliminate the inner string wash pipes requirement. And then on the SMP, the upper section, it was just more complexity of the gravel pack job requirements and so forth, and that's why they decided to change it to an SMP screen. The operator has had success in implementing both the SMP as well as the case hold, but they did see benefits in terms of complexity of the operation would be solved with the SMP. Now, just the general execution steps of what happened during the operations. So just running through from bottom to top again, you have, in this case, in order to plug the end of the assembly, we use an RFID toe sleeve, pretty much in order to block the bottom. And then you would have the MTV screens with AICDs. We have used swell packers to isolate the zones from time to time, depending on the design as well. And the upper zone was completed with SMP screens. And then we had a liner hanger instead of a gravel packer. And the swivel master was pretty much added just in case we had to rotate the strings and so forth as well. So if we did encounter any holdups, it will be the swivel master that would also help in general. We ran the completion to the bottom to TD. We pumped the RFID tags as well as the activation fluid already. Once the tags came down, we closed the lower completion string. We were able to pressure up, and that pretty much sets the liner hanger and so forth. Then once we're done, we take out the running tools, pull out a hole, and then we ran the upper completion to sting into the lower, where we pressured up even further in order to activate the MTVs. And that was pretty much a basic run through of the operations. Now, during this discussion of the wells, another limitation, as I mentioned, was on the temperature to use the SMP, because at the end of the day, an SMP is a polymer, and polymers are sensitive to temperature. At the time, the limitation for application was at 200 degrees Fahrenheit. So the well A was at 210 degrees Fahrenheit. So a question occurred that if we go over and apply it under, outside of the operating envelope, what effects would happen to the SMP screens? So we did do testings and so forth on that to see the effects. And if we're in the oil well hydrocarbons, there aren't any effects. That wouldn't be a problem. But we tested it to the extreme where it was 100% water production. And with that, at high temperatures, especially at around 230 to 240 degrees Fahrenheit, you would see hydrolysis degradation of the shape memory polymer. So that was the risk that was involved in pretty much installing it in a high temperature. However, after looking at the risks, we did go through an elaborate discussion about the risk and reward that was going on. The risk is definitely, if at high temperatures, it degrades, but the weld in question is only at 210, where we see slight degradation if there's water. And the test that we see this much degradation was with 100% water, while the well A didn't actually have that much water involved. So, however, if we go with the SMP, we would definitely lower the complexity of the completion strings and the operations and so forth. So in conclusion, after evaluating the risk and reward, it was a green light to go ahead with the SMP technology. Now, once we decide to go with the technology, we do test the activation fluid that will be used to expand the shape memory polymer. The activation fluid itself is acetyl acetone. We call it for short ACAC. So there are many ways on how and what base fluid you will be pumping the activation fluid with. In this scenario in specific, we mixed the ACAC with the drilling SPM, filtered of course, because you wouldn't want to run solids with screens. And with that, what we found was that the properties of the drilling SPM that they were using was already accelerating the expansion of the geoform. So even without adding ACAC activation fluid, you just run the completion in the normal SPM. The shape memory polymer pretty much expands within 6 to 8 hours, which is too fast considering contingencies that could happen along the way while you're running in hole. You would definitely want around, at the very least, 16 hours or so, just in case you need to pull out of hole or anything like that. So that was one of the challenges. And another one was that once we mixed the activation fluid with the mud, the drilling SPM, we saw that the rheology has changed and it caused the mud to gel up. So after a few tests, we decided to add a thinner, and also once you add the thinner, the mud properties change and the results also change, and it was finalized to 3% ACAC inside the filtered drilling SPM with a 4 ppb thinner. And we got results in terms of the expansion. We were able to get expansion. So on your right is pretty much a table of the lab expansion tests we did. So the OD of the SMP screen starts at 7.25-ish. And once it sees activation fluid, you can reference the black line that we use at 3%. It goes up and it reaches gauge hole, which is 8.5-inch hole at around 20, I would say 30 hours approximately, which is an acceptable hour timeline for us. So that's pretty much how we decided that 3% was good. Other operational considerations are definitely in terms of the logistics and of how we're going to bring the fluids and the screens offshore. The screens are a little bit more sensitive because they are reactive to temperature. So special care needs to be when you handle the screens. And the activation fluid, since we are not mixing 3% onshore, but we are taking the full batch to mix in the mud pit offshore, 100% activation fluid is actually categorized as a flammable fluid. So we had a thorough review about the logistics, the packaging, and also the tanks to make sure that they are certified to handle the activation fluid required. In terms of logistics, we looked at the platform itself, tried to find the shortest way in order to mix it into the mud pit to reduce the risk as much as possible. So we put it on the tender pretty much near an entryway to the mud pit, and we used a hose to transfer it into the mud pit. And also we added customized stingers and piping to release the activation fluid at the bottom of the tank. And that's mainly to to make sure that it's not volatile. And because if you mix it at the top and it splashes down, it's just a lot more dangerous, volatile in general. So that's pretty much a few risks and precautions we took into consideration. And yeah, so that was pretty much it. We ran the job. It was a very successful job all in general. The well started producing in February 2020, and I have been having a bi-monthly checkup with the operator in terms of the performance of the well, and everything is doing great in both zones, the upper and the lower zone productions. So just as a summary of the whole presentation, introducing the multitasking valve, which can be incorporated into any conventional screens, inflow control device, or standalone as like on a base pipe is possible. And this pretty much eliminates the use of a wash pipe in lower completions. Then in terms of the SMP, we were able to justify the application in well A, and we definitely pushed the margins in terms of the operating limits of it, and considering the risk versus reward, and it was quite successful until now. But at the moment, we have solved that problem, and there are new materials in terms of the SMP that will withstand up to 250 degrees Fahrenheit now. So a lot of the wells will save from it. And all in all, like I did talk about the complexity of running gravel pack jobs, and that equates down to savings in terms of logistics, rig space, personnel requirements, as well as goes to HSE risk as well, right? If you want to capture that by a value of number, at the very least, it captured a saving of 2 million just for that well alone. But considering HSE risk, complexity of the operations, it definitely had a lot more benefits than your conventional gravel pack jobs for this well. So that brings me to the end of the presentation. Hopefully you enjoyed it and didn't go bored before. And if you have any questions, feel free to ask. I'm definitely willing to share the best practices and everything on it. Thank you very much. Really appreciate your time this evening to come and join.
Okay, thank you very much, Kun Parvinee. Yep, there's no question in the chat box yet.
Okay, that's
sorry,
no
go ahead.
problem at all.
Anyone want to ask?
Okay, may I ask the question? Good evening, Kun Parvinee.
Sure, please go ahead, Kun Chaemchaeng.
Chaemchaeng
Sure.
from Multitasking Thailand. I'm just curious to see the very nice to see the new invention, and thanks for sharing. I'm just curious that since this one is quite new to me, I haven't heard about MTV yet. This is the first time, and then
I think I lost you there.
Can you still hear me?
Mm-hmm.
Okay,
yes, we can hear you now.
Okay, good. Thank you very much. Okay, good evening, and thank you very much for sharing this information. MTV is the first time for me to see it and see the benefit we can apply to our completions. It saves a lot of time for the wash pipe. However, since it's fairly new, so I'm just curious that how many sets that you ran so far.
Correct.
And, any issue you have with your clients on the first run or first trial?
I have gone through the reliability report. Sorry.
Yes.
I'll go ahead and answer your first question first. I have gone through the reliability report of the technology. The technology definitely started with applications in the Middle East, and right now, in terms of well count installed, is more than 300-400 wells already. In terms of issues, we have not had a well where we had any problems in terms of activating the MTV at all. All of them were successful. However, I guess one of the concerns to share in terms of the technology is pretty much how to assure that that every MTV is activated when you pressure up, right? And for that answer, you don't have any option other than going in with coiled tubing and putting a pack off at each one to justify that. However, we do monitor the expected production against what we actually do. And on all the ones installed so far, we have no issues in terms of indications that there has been any plugging or the MTV has not activated. Most of the reliability parts we have was pretty much raised issues on how we test the MTV at the workshop to ensure that the shears were actually, the shear pins were actually sheared and so forth. But that is at the workshop level that we see. Did that answer your question?
Sure, yeah, thank you very much. And you also answer my future question in advance because I'm planning to ask you about the contingency plan just in case if something happened that premature activate the valve. Thank you very much, Parvinee.
Correct. For sure, but they say that sometimes in some wells, because every joint, the activation, the activation pressure would be the same for every MTV joint. So there are times where you can actually see an indication of it being sheared at the rig floor. But apart from that, you can't really have any indication until you actually produce after.
Okay, thank you very much. Very nice to see new invention.
Yeah, definitely.
Okay, Kun Pa, maybe question
It's
from me.
interesting though. It's a technology. Yeah.
Oh, sorry, go ahead.
Oh, I was just saying that it's interesting though, because the MTV technology has been around for decades, but I feel like it hasn't been introduced into the Southeast Asia or APAC, Asia Pacific market in general for the benefits of it yet. I do know that there are technologies that serve similar applications though, as well, just to share in terms of the technology itself.
Thanks, Kun Parvinee, Panit from Mubala Petroleum as well. Just curious that I believe many operators already have their own screens in inventory. How could we manage to install this MTV, and is that still cost competitive? I mean, from the logistic, from the installation and utilization, all this.
I would say that the MTV at the moment is the technology. At the moment, the MTV is applicable to any screen from the same company, but it hasn't been adapted to be compatible with screens from outside the company yet. I do not see it as being a roadblock in terms of doing it, but you would have to have an adapter from the housing of the MTV to the current screens that you have. It hasn't been done, but yeah. Did that answer your question? Sorry.
Yes, thank you. I mean, maybe last one from me. On the shape memory polymer, I try to use the general term here. In shape memory polymer, you did mention that it's not really competitive when comparing to gravel pack, right?
Competitive in terms of performance
total cost,
or
I mean, total cost of ownership, for example.
Okay. Okay. In terms of commercial, I would say that it depends on the open hole length that you have, because it varies. If it's like a shorter open hole length, I would say definitely the shape memory polymer would have advantage in terms of commercial. But if it's long open hole lengths, I would say a conventional gravel pack would be more commercially justifiable. However, there are extended reach wells, which there has been implementation of the shape memory polymer in Russia, which are very long intervals and of the open hole, and a standard gravel pack would not be able to accommodate that, because gravel pack jobs, you are limited in terms of the open hole length that you can do. But with the shape memory polymer, you do not have that limitation. So with very, very extended wells, the shape memory
I think we lost her in the process.
Sorry, can you hear me now? Not sure where I left off. Hello?
Yes, you're back now. I think we
Sure.
lost
I'm not
you
sure
a bit.
Okay, I'm not sure where it cut off, but yeah, on terms of commercial wise, short intervals of open hole, the SMP screens will be more commercially justifiable, but with long open hole intervals, I think gravel pack will be more commercial, but really long wells, like extended reach wells, you would not be able to do a conventional gravel pack because there are limitations in the technology. So that's where you would switch back to having shape memory polymer being the better applicable in terms of the technology of it. But if you're talking about performance-wise comparison, from the data we have, performance-wise, the shape memory polymer is equivalent or better than a gravel pack job. There is actually a paper on OTC of a field that compares between a conventional gravel pack, open hole gravel pack, a case hole gravel pack, and the shape memory polymer installations in the same field. And production-wise, definitely the shape memory polymer was better. And that's mainly also because of the skin factor as well. Because with a case hole gravel pack, you would know that the skin factor would be very high. Open hole gravel pack as well, less than great case hole, but open hole gravel pack, you would still have the same. But with a shape memory polymer installation so far, skin factors are equivalent to a standalone screen. So that's where the production-wise performance is actually sometimes better, but definitely equivalent plus. Yeah.
Thank you, Khun Parvinee. Any other question from the floor?
Yeah. Hi. Good evening, Khun Parvinee. Just a curious one. I'm not from completion background, so probably have no idea what you're talking about for the last 20 minutes. But
No problem.
just a curious questions on. Do you have like a hybrid systems that have the conventional like whatever gravel pack combined with this SMP for extended reach well? Just like a combined hybrid system or no?
Application wise, no, we have not done that before, but that will, because it will kind of deplete the purpose of it, right? Because if you're considering a gravel pack job and you mix it with, you mix the two, means that you already have the pumping on location and so forth. So if you already have to account for that commercially, going ahead with the full gravel pack job would definitely be more commercially viable and a better solution to go with. Combining the two, it can be done, not that it can. You can have one zone as the shape memory polymer and another zone as the gravel pack. It can be done, but just justifying the commercial, I think, would be hard. Did that kind of answer your question, just to make sure?
No, yes,
Okay.
yeah. Just want to see if there is any previous cases of a combined technology. Just curious, out of curiosity. Yeah. Thank you.
No problem. Technology-wise, it can be done. But one thing, if you're combining in terms of using shape memory polymer screens for a gravel pack job, combining it in the same zone, that cannot be done. But if you separate the zones of each technology, that can be done, no problem. Okay. Any other questions? Feel free to ask.
Yes, good Parvinee. This is Ronald here.
Hi, Ronald.
Just a quick question there about the hole size. You basically use your example for 8.5-inch hole. Have you run this in a 12.25-inch hole, or can you not, or is there any limitations?
That's actually a really good question. The technology right now is, I'm speaking for only one company, I guess, but you can check on other companies. But from my company, at the very least, we have released the technology with only 2 sizes. So it's available in a 3.5-inch and a 5.5-inch. So the 3.5-inch is for a 618-inch hole, and the 5.5 for an 8.5. So going up to 12.25-inch, the technology is not available at the moment, unfortunately.
Yeah, okay. Just want to check. Thank you very much.
That's a good question. We have done a survey before, and there hasn't been a huge market for that size, though.
I would think that in the Middle East there would have been, but maybe not. Yeah, if you run a big completion, especially I'm thinking for oil wells, yeah, you might wanna, you might be, yeah, you're gonna increase your oil production significantly, and you run your screens in a bigger hole. So, yeah, I think that they're probably gonna request, they're gonna ask for it for sure. Thank you.
That would be interesting to see. If they do, I'll come back with another presentation for that case history.
Okay, any other questions from the floor? Counting 1, 2, 3.
An auction.
An auction. All right. Thank you very much, Kun Parvinee. So just to close out, of course, the last slide would be our sponsor. So we reach the end and conclude for our webinar for today. And thank you for staying with us. If you have any feedback on where we could improve on our online session, or any topic that you would like to hear, then please feel free to, you can send a message in our Facebook or LinkedIn, or even drop email to us. Then we'll get back to you and try to improve next time. And thanks again to Kun Parvinee, and also, of course, our section sponsor here in front of you. So enjoy the rest of the evening, and good night on behalf of SPE Thailand. ขอบคุณมากครับ สวัสดีครับ
สวัสดีค่ะ Thank you ค่ะ